Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shehroz Abdullah and today we are going to discuss what is significant figures and what is rounding off. Let me recall the previous work that we have done. If you remember, in the previous work we have discussed with a screw gauge, we have defined screw gauge, we have discussed the least count of it, we have discussed the pitch of the screw, right? We have discussed how to take reading with the screw gauge and all the things related to screw gauge we have discussed in the previous lecture. Now today we are going to discuss what is significant figures. You know, significant figures are all those figures about which we are reasonably sure, and the first doubtful figure is known as significant figures. We can also define it like this: all those figures, all those accurately known figures, and the first doubtful figure is known as what? Significant figures. First of all, we need to understand what is doubtful figure, what is accurately known figure. Now let's come. Look, we can define it like this: all those figures about which we are reasonably sure, and the first doubtful figure is known as significant figures. Second definition is all those accurately known figures and the first doubtful figure is known in the expression is known as significant figures. For example, a person finds the length of a book. For example, if we have two students, first student find the length of the book 17.4 centimeters. Second student find the length of the book 17.5 centimeters. In this reading, if we see 17 is common in both the readings, means this 17 is accurately known digit. This 17 is what? Accurately known digits. Now this 0.4 and 0.5, we are not sure about that which reading is correct. This 0.4 and 0.5 is known as doubtful figures or doubtful digits. So this is what we call significant figures. In significant figures, both the things included: accurately known digits and doubtful digits, and the first doubtful digit, not all, first doubtful digit is known as significant figures. Look, in this case, if a student measures the length of a book as 17.4 centimeters and second student measures the same length of the book as 17.5 centimeters, so in that case 17 is common in both, so means that is accurately known digit, accurately known significant figure, while 0.4 and 0.5 have some doubts in it, right? So we are not sure about that, so this 0.4 and 0.5 is known as what? Doubtful figures. Done ho gaya? Okay, this whole is known as significant figures. Now to find out significant figures in a reading, in a measurement, there are some rules, there are some criteria on behalf of which we find the significancy of a certain reading. The first is, there are some main points. Number one, all the non-zero digits from 1 to 9 will be significant. All the non-zero digits from 1 to 9, like 1, 2, 3, 4, 5, 6, 7, 8, 9, wherever you see these digits, they will be significant. Done ho gaya? Look, 2, 9, 1, 3, 9, 8. If we have a reading like this, okay, how many significant figures they have? 1, 2, 3, 4, 5, 6. 6 significant figures we are having over here. Done ho gaya? Okay, now what is zero? What is zero discussion? Look, about zero we have three rules. Look, if zero is to the left of the significant figures, then they are not significant. If zero is on the left side of the significant figures, they will be not considered as significant. Why? Look, 0.00259 we have this number. In this reading, these 0.00, these 0 are on left side of what? Significant figure. That is why they are not considered as significant figure. Okay. Now, if we find how many significant figures we are having in this reading, so we say 2, 5, 1, 2, 9 means 1, 2, 3, 4, 5. 5 significant figures we are having over here. Done ho gaya? Now, if 0 is between two non-zero digits, if 0 is between two non-zero digits, that 0 is then significant. For example, if 0 is laying in between two non-zero digits, then it will be, then that 0 will be also significant. For example, 509. Does this 509 means 59? No, never. It means 509. So it means 509. In 509 we have three significant figures. How much? Three significant figures. So what is the rule? If 0 is in between two non-zero digits, so that 0 is also significant. Done ho gaya? Now coming towards zeros on the right side. Look, 0 to the right side of the significant figures may or may not be significant. Look, if 0 is on the right side of the significant figures, they may be significant, may not be significant, depending upon the accuracy of the measuring instrument, depending upon the accuracy of the measurement. For example, we have a reading like 25,000. Okay, we have a reading 25,000. Over here we may have one significant figure as well, two significant figure as well, even five significant as well. We are not clear that which zeros are locating, like which zeros are served to locate the position values or and which zeros are part of the measurement. We are not sure about that. Okay, like in 25,000, since zeros are on the right side of the significant figures, they may be significant, may not be significant, depending upon the accuracy of the measurement, accuracy of the measuring instruments, right? Over here, now we are not clear about that which zeros are serving to locate the position values and which are actually the part of the measurement. Okay, what we do in such cases? In such cases, we have to express the value in scientific notation. Like we have to express this value in scientific notation like this. If you express this value in scientific notation, so that will be 2.5 into 10 raised to the power 4. Okay. Now remember, whenever a reading is expressed in scientific notation, rules will be applied only on mantissa part. Like if we express this number in scientific form, we will apply rules on this mantissa part only. We have no concern with the power of 10 form. Okay. Now in this 2.5, if we see in the above example, we have just two significant figures like 2 and 5. These are two digits which are significant over here. Done ho gaya? Okay. Now this was all about significant figures. Now moving towards next topic, that is rounding off. Moving towards our next topic, that is rounding off. You know, rounding off is that phenomena, is that process by which we can simplify our result. That phenomena, that process, that method, that technique through which we simplify our final result, that is known as rounding off. There are three basic rules. Number one, if the last digit is less than 5, we have a certain reading. If the last digit is less than 5, so what we will do? Then it will be ignored. For example, we have a reading 2.6. Now, for example, we have a reading 2.6563. Done ho gaya? Now, see the last digit. That last digit is 3, which is less than 5. So we will ignore the last digit and we will round it to 2.656. Done ho gaya? This 3 will be what? This will be ignored totally. Okay. Now come towards rule number 2. If the last digit is greater than 5, so second last digit will be increased by 1 and last digit will be ignored. Look, we have a reading 2.6568. Done ho gaya? Last digit is 8, which is greater than 5. So we will round it to 2.656. Done? Okay. Now where is the problem? Problem arises when the last digit is exactly 5. When the last digit is exactly 5, then problem arises. Now look, we have two cases over here. If the last digit is exactly 5, if the last digit is what? Exactly 5. So what we do? we observe the second last digit. If the second last digit is even, so what we do, no changes observed, only last digit will be ignored. Like last digit is 5 and second last digit is even, so last digit will be ignored, okay, and no changes will occur. For example, we have a reading like this, 2.6545. Last digit is what? Last digit is exactly 5. Okay, so what we do, last digit is only ignored, no changes observed, so this will be 2.654 only. Done ho gaya? Now, if the last digit is 5 and second last digit is odd, if the last digit is 5 and second last digit is odd, so what we do, we ignore the last digit and increase the second last digit by 1. Look, if we have a reading 2.6515, okay, now last digit is what? Last digit is 5. Okay, what is second last digit? Second last digit is 1, which is odd. So what we do, we ignore the last digit and round it to 2.652, right? So this was all about rounding off. Done ho gaya? So today we have discussed 2 lectures, significant figures and rounding off. Let me summarize today's work once again. Okay, what is significant figures? All those figures about which we are reasonably sure, and the first doubtful figure is known as significant figures. Done ho gaya? For example, if we have 2 students, student 1 finds the length of a book 17.4 centimeters, second student finds the length of the same book as 17.5 centimeters. In both the cases 17 is common, which is accurately known digit. Done ho gaya? 0.4 and 0.5 have some doubts in it. They are also significant figures, they have some doubts in it. These are first doubtful digits. Okay, now there are some main points with significant figures. Wherever you see non-zero digits like 1 to 9, they will be always significant. Done ho gaya? For example, over here we were in this case we were having 6 significant figures. Okay, now we discuss 0. If 0 is on the left side of the significant figure, they will be not significant. If 0 is between 2 non-zero digits, for example 509 never means 59. Okay, it means 509. So 509 means they have 3 significant figures. Done ho gaya? Okay, now coming towards zeros to the right side. If zeros is on the right side of the significant figures, so they may or may not be significant depending upon the accuracy of the measuring instrument. Okay, for example, we have 25,000, it may have 1, 2, 5 significant figures. We are not sure about that. What to do then? We have to convert this value into scientific notation. Whenever it is shown in scientific form, we apply the rules on mantissa only, not to power of 10. Power of 10, and on power of 10 we don't apply the rules. Okay, we apply the rules only on mantissa in that case. For example, in that case we have only 2 significant figures, that is 2 and 5. Done it? Okay. Next, coming towards rounding off. Rounding off is that process by which we simplify our result or calculation known as rounding off. There are 3 rules of it. If the last digit is less than 5, last digit will be ignored and will be round and no changes will be observed. Done ho gaya? Okay. Coming towards second rule, if the last digit is greater than 5, what we do? We ignore the last digit and increase the second last digit by 1. Okay. Now third rule, where is the problem? If the last digit is exactly 5, what to do then? We see the second last digit. If second last digit is even, so ignore the last digit and no changes observed, and there will be no change, right? Just last digit will be ignored. If the last digit is if the last digit is 5, exactly 5, while second last is odd, what to do then? We ignore the last digit while second last digit will be increased by 1. Okay, so this is how we have done with this. Okay, so this was today's lecture, right? We have discussed significant figures and rounding off. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz, fi aman Allah.